Hello, dear students. So previously we have covered the first chapter of your NCERT Maths class in at 12th. That is your relations and functions. So now we will see the next chapter of class 12. That is inverse trigonometric functions, and it is also very important chapter for your like board exam and also for your JE and your school exams. So let's find out that what is in this chapter. To start with the introduction part. So in chapter 1, we have already studied that inverse of a function is defined as f inverse, that we denoted it like with f inverse, and it exists if f is 1 1 and onto both. Okay, if f is 1 1 function also and onto also. We have already discussed what is a 1 1 function and onto function. So you can go to the lectures and the playlist and see the like what are these topics, and then go through this chapter. So there are many functions which are not one one onto or both, and hence we cannot talk of their inverse. If the function is not one one and onto, then we cannot talk of their inverse. Why we cannot find the inverse of that function? That also I have told in the first chapter, so you can refer to that also. Okay. And in class 11th, we have studied that trigonometric functions are not one one and onto over their actual domains and range. So basically, you have already studied that what are the trigonometric functions like sine, cosine, and tan, cot, sec, cosec. So if you remember the graphs of sine and cosine, so sine is like your like this. Okay. So is it one one or onto? No. Why? Because if you see here, then here the function is like repeating its value. It is periodic. So 1 1 is not there, because if you draw the any line parallel to x-axis, it will cut more than one point on the graph. So it is one not 1 1. Okay, it is not 1 1, and it is also not many onto also, not onto also. Why? Because its range is not covering all the points in the real number line. Okay, it is not here onto also, not onto also. Okay, so we will see that how we can find the inverse of trigonometric function. If we define any interval, then we can find the inverse of that function. If we define any trigonometric function in any domain, if you take some specific point, then we can find out the inverse of that function in that interval. In the trigonometric function should be 1 1 also and onto also. So we will see that. Okay. Yeah, let's move on. See what is the next thing. Okay, just I will clear this time. Okay. So in this chapter, we shall study about the restrictions on domains and ranges. That I already told you that there are some restrictions on domains and range of trigonometric functions, which ensure the existence of their inverses and observe their behavior through graphical representation. So that will be your inverse criteria, and that will also be like covered through graphs here. Besides some elementary properties, we will all be that will also discuss that we will see some elementary properties also. The inverse trigonometric functions play an important role in calculus also. So inverse trigonometric also are used in calculus very much, and that is why they are used in like integrals, differentiations. Okay. So let's see what are the like basic concepts in this. So in class 11th, we have already studied that trigonometric functions, which I already told you in previous topic, that there are sine, cosine, tangent, cotangent, and secant and cosecant function. So let's recall that functions and what are the domains and ranges of that. We will see. So for sine function, that is sine is domain is a real number, that it is defined for all real numbers. You can see that the graph goes like this. So all the real numbers are covered here. If we can draw it here. Okay, so all the real numbers are covered here. So domain is real number, and the range is -1 to 1, because the graph goes only from -1 to 1. Range is -1 to 1 only. So that is given here, that -1 to 1, that is in closed interval. So these all both the points will also be in the domain, like range, sorry, in the range. -1 and 1 or will be in the range. So cosine function is similar to like sine function. The domain is real number and range is -1 to 1. Similar like domain and range are there. Tangent function is defined for real number minus x. That is x is what here? That is equal to 2n plus 1 pi by 2, where n is belonging to integer. So what it says that tangent function is only, like tan function is only defined for what? Like it is defined for only your at a point where real number are there, but it is not defined on. You can say that pi by 2, then like 3 pi by 2. Okay, at that point the graph is like tending towards infinite, or it is not defined here. So you can say that tangent function is not defined for these points where n belong to integer. So this like this definition is for like pi by 2, 3 pi by 2, 5 pi by 2, like that. Okay, minus pi by 2. For these points, this definition is there, that the function is not defined here. The domain is like not containing these points. Only all real number will be contained, but these points are excluded from this. And the range is real number, all real number, because range should be there, like the graph is containing all the real numbers here. The range is your all real numbers. Okay, yeah. So that is your tangent function. And what is cotangent function? It is like just opposite or inverse of like cotangent is like 1 by tan. So whatever will be the like points where tangent function is like its domain is not defined. So similar to that, cotangent function has the domain is like range minus x, where x belongs to n pi. Okay, and x belongs to n pi. Why is that so? Because that n pi, like tan function will become 0, equal to 0, and 1 by 0 is not defined. So that is why n pi points are excluded from this. And that in the here it is also written that r is minus n pi, like these points are not defined. So like pi, minus pi, okay, 2 pi, 3 pi will be excluded from the domain of cotangent function. And the range is like real number, all real number, because similar to tan function, cot also is defined for your real numbers. Okay, so its graph will be like this, it will be like this only. Okay, tan from cot function. So basically your this is for your cotangent function. And second function is just opposite of what? Cosine function. That is second is your 1 by cos. Okay, so it's the like domain will be what? Real number minus x, and x will be 2n plus 1 pi by 2. So you can see that there is a similarity between the second function and tangent function. Why? Because tangent function is also can be written as sine by cos. So where the points where cos is not defined, like where cos value is 0, okay, cos value is 0, that point should be excluded from the domain of tan. Similarly, for sec also, the cos is 0, the point at that like domain is excluded. At that point, the that point should be excluded from the domain. So that is why the tan and sec have the same domain, that is real number minus x, where x is 2n plus 1 pi by 2 and n belongs to integer. And range is what? Range should be r minus 1 comma 1. That is this is why, because you can see that the second function is the graph of second function is like this, that you have the graph is finding, like you can see that the graph is like this only. Okay, so the points you can see that the graph is showing this behavior. So if you see that there is a range, what is range? Range is covering all the real numbers, but it is not covering the interval -1 to 1. That is why real number minus 1 comma 1 is excluded from the range of -1 comma 1 is excluded from the range of second. And similarly, cosecant function or cosec function is like opposite of your sine function. and that is why the domain of it is also defined like domain of cotangent function, because cot is also can be written like cos by sine. A similar analogy is that where is the sine function is zero, that point should be excluded from the cot also and from cosec also. So the domain of cot and cosec, you can remember that it is similar, and this is r minus x, where x is n pi. The numbers like pi and pi, 2 pi, 3 pi, 4 pi are excluded. Minus pi, minus 3 pi, minus 2 pi, these are excluded from the domain of cosec, and range is similar to what? That is sec function, r minus minus 1 to 1. Because the graph of it is also like this only. Okay, like this only. So you can get the points like this. Okay, minus 1 comma 1 interval is excluded from here. Like this is minus 1 comma 1. Sorry, this is minus 1 and this is 1 point. Okay. So these like we have just to recall the your trigonometric functions and their domains and range, and we will now move to the next page and see whatever in the next page is. Okay, let's move. So yeah, we have also learned in class 11 that f is a function from x to y, so that fx is equal to y is 1 and on to, then we can define a unique function g that is from y to x, such that gy is equal to x. Okay, this we have covered in not in 11 but chapter 1, relations and functions, that if a function fx equal to y in 1 and on to, then we can define any other function that is g on that is from y to x, and we can also say that gy is equal to x, where x is belonging to capital X and y is equal to fx, y where belongs to capital Y. Here the domain of G is range of f. So the domain of G will become here range of f. Okay. And the range of G become the domain of f. Okay. Because the function is inversed here, so the domain and range also should be interchanged here. The function G is called the inverse of f and is denoted by f inverse. So we can write the G function as also as f inverse. Further, G is also 1 and onto, and inverse of G is f. And similarly, we can say that it is obvious G is like inverse of f. So we can write G inverse as f inverse of inverse. So it is coming out to be equal to f. So if f inverse is G, then G inverse is f. We also have f inverse of O f x is equal to f inverse of fx, that is equal to x. And f O f inverse of y is equal to fx, that is equal to y. Okay. Then the domain of sine function is the set of all real numbers and range in the quotient interval minus 1 to 1. We can restrict it domain to minus pi by 2 to pi by 2. So I have already told you that the sine function is not 1 and on 2 in the whole domain of its, because it if you see the graph of sine function, it is like repeating its value for many points. If you can say that it has one value, so one is coming at pi by 2 also, then it is coming on pi by 2 plus 2 pi, then pi by 2 plus 4 pi, so it will repeat its value. Okay, so it is not 1 and also not on 2, because the range is not covering all the points in the real number line. It is not 1 and on 2 in the whole interval. So we can restrict the domain to minus pi by 2 to pi by 2. Okay, then it becomes 1 and on 2 with range minus 1 to 1. Okay, yeah. So I will show you that why it is becoming 1 and on 2 in this interval. Let's find out. Okay, just a second. I will rub this. Okay. Yes. So if we want, we can restrict our interval any, like minus 3 pi by 2 to pi minus pi by 2, minus pi by 2, pi by 2, pi by 2 to 3 pi by 2. In these all intervals, the function is like 1 1 also and on 2 also. But we will generally take it like minus pi by 2 to pi by 2 because it is a principal interval. Means that it is the your primary interval, that is in this interval you can find the sine function as 1 1 and on 2 also. Okay. So yeah, if we recall the sine function, so it is like what? Pi by 2 to pi by minus pi, like I have told you that minus pi by 2 to pi by 2. Okay. So how is the function in this interval? If you recall the graph of this, so what is the graph of sine function in this interval? Like it is as pi by 2 it is 1. So here it is value and here it is minus 1. Okay. So the graph is like this. Yeah. The graph is like this. So in this interval, you can see that the function is like 1 1 because it is uh, if I draw the line parallel to x-axis, it will cover only cut only at one point to the graph. Okay. And it is also here like onto also. Why it is onto also here? Because you can see that whatever the range of your sine function is, like sine function as the range is covering minus 1 to 1. Okay. So if I only consider this range, so for this range, this points, this interval is covering all the points here. Okay. So for this range, if I define the function is covering all the all the range it is covering. That is minus 1 to 1. It is covering all the points of range, and also uh, it is like you can see that all the points are covered here, and it is on 2 also in this interval. Only this in this interval it is on 2. But if you consider whole graph, then it will be not on 2 because whole like real numbers are not covered in that interval. Okay. So here it is given also in your book. You can see here the branch with range minus pi by 2 to pi by 2 is called the principal value branch. It is called principal value branch where other intervals at range give different branches of sine inverse. Okay. And other branches will give different value like branches of sine inverse. That is not the principal. This is called the principal branch. So if anyone ask you what is the domain of sine inverse function, so you must say him that the domain of your like your what is your range of sine inverse. The sine inverse is basically in means covered in which range? It is covered in minus pi by 2 to pi by 2. That should be remembered. It will be minus pi by 2 to pi by 2. Not all real numbers, but pi by 2 to pi by 2. Minus pi by 2 to pi by 2. Okay. Okay. So we take it as a function whose domain is minus 1 to 1. So domain will be minus 1 to 1 and range is minus pi by 2 to pi by 2. I have already told you the range will be this. We write sine inverse like to minus 1 to 1 and pi by 2. So it is clearly defined here. The sine inverse is defined from minus 1 comma 1. That is the domain of sine function, and from range, and it is defined to range that is minus pi by 2 to pi by 2. So this should be remembered. Okay. Close interval in the both sides. So that is very important formula for you, that what is the domain and range of sine function, that is minus 1 to 1 comma which is defined from minus 1 to 1, and range is pi by minus pi by 2 to pi by 2. Okay. From the definition of inverse function, it follows that sine of sine inverse x is x. Sorry. So you have if sine and sine inverse x. So what it will give you? So you are just think of that. Sine inverse x will give you what? This is inverse of any, like trigonometric inverse will always give you any angle. So sine inverse x is giving you any angle. So sine inverse of this is any angle to you, and you can see that sine inverse of x will be if any angle, like you can say theta. Okay. So it will give you what? It will give you like your x only. Okay, x only. You will get x only because if y is equal to sine of x, then sine y is equal to x here. Okay, so basically sine and sine inverse will cancel out each other, and they will give you the value. Theta will be given as your this x only. So this will give you x only. Okay, this will give you x value only because sine and sine inverse will be cancel out here. So x will be the answer of this. And here x is minus 1 to 1, that I have already told you that this is the domain of that. And sine like sine inverse sine x is minus pi by 2 to pi by 2, x is minus pi by 2 to pi by 2. Okay, so this is like sine inverse sine of x, and that is sine of sine inverse x. So this is for your like sine function, and this is your sine inverse function. So here x is from minus pi by 2 to pi by 2. In other words, we can say that y is equal to sine inverse x and sine y is equal to x. So this is obvious thing. Okay. Now let's move to the next page, and I will clear this drawing. Yeah, just a second. Okay, so how the graph of sine inverse x can be obtained? So remember one thing, that if you want any inverse graph, you should take the mirror image of the original graph in the like interval which which is onto an in one one, and you should take the mirror image of that graph about the y is equal to x axis. Okay, so let's find out the mirror image of sine x. So I will show you how it comes. If you have sine x function, so I have already told you that it is 1 1 and onto in this interval only, like this, minus pi by 2 to minus pi by 2 to pi by 2. Okay, this is pi by 2 and this is minus pi by 2. This is your y equal to sine x, but you have to just find the inverse function graph. So remember that the line of y equal to x will be what? It will be like this. Okay, y equal to x will be graph like this. Y equal to x is the graph is above the your sine x graph. Okay, because it has the like more slope than your sine x. So if you take the mirror image of this about this axis, so how will you get the graph? You will get it like this. Okay, and for this graph, what you will get? You will get it like, just a second. Okay, yeah, yes. So you will get it like this, and for this part, you will get what? For this part, you will get it like here you will get like this. Okay, so you have seen that the graph of sine inverse x is also drawn here. Okay, so I will draw it in separate part, that how it has come. Yeah, so sine inverse graph is like this. If I remove the sine x graph, so sine inverse graph is coming like this only. Okay, like this and this. Okay, so this is y equal to sine inverse x graph. And what is this? This is your one value, and this is minus one value. Okay, so this is what? This is your domain. Here the minus one to one is becoming your domain for here. Okay. Yes. Just a second. I have to draw it 1 second. So this is minus pi by 2, and this is your pi by 2. Okay. So this is your range, and minus 1 is this point. Okay. Minus 1 point is your like this, minus 1, and this will be your plus 1. So your domain is what? Minus 1 to 1. Okay. And your range is, you can see that, minus pi by 2 to pi by 2. So range is becoming as minus pi by 2 to pi by 2. Okay. So I have clearly shown you that how the graph of a sine inverse is formed here by taking mirror image about the y equal to x-axis, and it has come like this only. Okay, like this. So just I will remove this part and see other things in this. Okay. Yes. It can be shown that the graph of an inverse function can be obtained from the corresponding graph of one. This is also, I have covered that it is reflection along y equal to x only. Okay. Like sine function, the cosine function is a function whose domain is the set of all real numbers and range the set of -1 to 1. Okay. So similar to sine, which I've defined like it is 1, 1 and on 2 in the interval minus pi by 2 to pi by 2, we can restrict the domain of cosine function from 0 to pi. Why 0 to pi? See here, what is the graph of your cosine function? Okay, cosine function graph is like this. If you can recall it, then its graph is like this only. So what is this point? This is 0. And what is this pointer? This is pi by 2. This is pi. Okay, and if you see here, then this point is what? This point is your minus pi by 2, and this is pi. So in which interval is the cosine function is 1, 1 and onto also? Okay. So you have to see that English interval is the 1, 1 and on 2. So let's find out that, yeah, this is pi only. This is pi and this is your pi. Okay. I have drawn like this is your 3 pi by 2. This is pi only. Okay. So if you separately see the graph of cosine, so in the interval 0, that is coming here, graph is coming from here, and this is your pi. This is your pi. Okay. So graph is here. You can see that here it is 1, 1 also and on 2 also. If you define the interval only like -1 to 1, -1 to 1, then in this range, this is 1, 1 also because it have only one cutting point if we draw the x-axis parallel line, and that is it is all also on 2 also in this interval. Similar to sine that we have drawn the function. Okay. So yes, we can find out where is the cosine is 1, 1 and on 2, that is 0 to pi. So this is what? This is the range of this function. And what is the domain of this function? It's cos inverse. That will be domain will be -1 to 1, similar to sine, but the range will be here 0 to pi. Okay. So this is your domain and this is your range. So let's move to the next page and see what are the other things. Okay, so similar to sine function, you can restrict the interval of cosine also in intervals like minus pi by pi to 0, pi to 2 pi, etc. is also bijective with range as -1 to 1, but we should take the primary interval that is equal to 0 to pi. Okay. Okay, so corresponding to each such interval, we get a branch of the function cosine or cos inverse. The branch with range 0 to pi is called the principal value branch. So I've already told you that sine has the principal value branch minus pi by 2 to pi by 2. Similar to that, the principal branch of your cosine function is 0 to pi. Remember these things, that it is the principal branch value branch of function cosine inverse is 0 to pi. Okay. So cos inverse has the domain, I have already told you, -1 to 1, and range is 0 to pi. And graph, I can tell you that it is like if you have graph of cosine function, how is this function? Like graph is what, like it is like this, and you have the like uh, y is equal to x, graph is like this only. So if you take the like mirror image about this axis, y equal to x axis. Okay. Just a minute. Yeah, I should make this y equal to x as a little bit upper side. Yeah, y equal to x will be like this only. Like it will form like this, y equal to x. Okay. So The mirror image about y equal to x will be what? It should come like, if you take this in, like this is will be your y equal to x. Yeah, the graph will be like this only. Like it will be like this. This is the mirror image about this axis, and for this part here, like this is your part for this part, okay, and for this part you will get like this only, okay. This. So your graph will look like what? If you see the graph of cos inverse x, so it will look like this and this, okay. So here it is your pi, and this is your 0 point, and this will be your like pi by 2 point, pi by 2, and this is 1, okay. This is 1, this is minus 1. This point is -1. So your graph will look like this of cos inverse x, okay. Cos inverse x will look like this. I hope you got this. And yes, okay. So till now we have seen that what is the graph of sine, like a cos inverse x look like, and we will see other parts also of this. So let's find out that what is the next topic. I will remove these drawings. So that is all about your sine inverse and cos inverse functions. And let us now discuss cosec inverse and cosec inverse x and sec inverse x as follows. So the most important inverse functions for you are cos inverse x and sin inverse x. Also tan inverse x is important, but your sec inverse x and cosec inverse x are not so important. You should have some idea of that, but you must have the idea of cos inverse x and sin inverse x, and tan inverse x are really important for you. Okay. So since cosec x is 1 by sin x, okay, you should remember this one, that cosec x is 1 by sin x. The domain of cosec function is the set of this, that is x not belonging to n pi, and the range is the set of this, like this. I have already told you the range and domain of this function, cosec function. Okay, that it means that y cosec x assumes all real values except -1 to 1. Okay. So like y is equal to cosec x assumes all real values except y -1 to 1. That I already told you that -1 to 1 interval is excluded from its range also. Okay. And is not defined for integral multiple of pi. It is not defined for integral multiple of pi, that is already told. If we restrict the domain of cosec x function to minus pi by 2 to pi by 2 minus 0, then it's 1 1 and onto with its range as the set r minus -1 to 1. So the domain of cosec function should be in the line like minus pi by 2 to pi by 2. Okay, why? Because you can see that the graph of like your cosec function is how. If you can recall it, then we can find out that cosec x function is your like it is minus pi by like minus pi by 2 to pi by 2. You can see the graph behavior inside this interval. If you draw the graph of this, then it will look like what? Okay, just a second. It will look like this only here, and here it will look like your just a second. Yeah, here it will look like this. Okay, so graph will be like this, and it will be like minus. You should not cover this point 0 point, because here it will not be defined here. Like it will not define here. So this interval only you should cover. So it will be 1 1 and on 2 in this interval, and its range will be r minus -1 to 1, that I already told you. So cosec interval, cosec function is extended to any interval of like this, minus pi by 3 pi by 2 to pi by minus pi by 2 minus pi, minus of minus pi, and minus pi by 2 to pi by 2 minus 0. So these all intervals are like where the function is your 1 1 and on 2 both, and it also like it is also bijective. That is 1 1 and on 2 is also called bijective. So it is bijective also in this way. And it's saying is the set of all real numbers r minus -1 to 1. Okay. So that is already I have mentioned here. So let's move to the next slide. Yes, see here, which I told you just before, that the graph of like cosec x is what, like this only. In the interval pi by 2, it is like this, okay, and from minus pi by 2, it is like this only. Yeah. So in this interval, it is 1 1 and also and on 2 also, because if you draw the line to parallel to x axis, it will cover only like cut only at single points, and also in the like range defined in this interval. Like if you have a range like real number minus 1 to 1, so it will cover all these points in this interval, and that is why it is called as onto also in this interval. Okay, so that is why the function has the corresponding range minus pi by 2 to pi by 2 minus 0 is called the principal value branch of cosec inverse x, because it is defined in this interval only. So it is called the principal branch value of cosec inverse x. Okay, so we have principal branch, like if we see that cosec inverse x has the domain is what? Its domain will be r minus minus 1 to 1. Okay, r minus minus 1 to 1 is the domain of like your cosec inverse x. Okay, and its range will be what? Minus pi by 2 to pi by 2, because in this interval only the graph is what? 1 1 and on 2. I have already shown you. And domain is your like real number, all containing its real number. You can see that it is containing all real number, but minus 1 to 1 interval is missing here. So that is why its domain will be like that. And the graph will be, if you take the like mirror image about y is equal to x. Okay, so y is equal to x. If you take the your mirror image, so it will be looking like this, and this, and this. Okay, so that will be the graph of cosec inverse x. Okay, so I hope that you have like you must have got what I told you, and we will see like other branch trigonometric functions also, inverse function also in the next topic. Okay, just a second. Give me a second. We will solve another topic, or try to read out the topic. Just a second. Okay. So yes, let's move to the next topic. Uh, so after cosec inverse x, we have the like other function which is sec inverse x. So similar to cosec inverse x, you can like analogy to sec inverse x also. So we should define an interval where it is 1 1 and on 2. In that interval, we can like find out that it is 1 1 and on 2 in that interval. So that will be what? Minus pi to 0 minus pi by 2. Why that so? Because in like your minus pi to 0, see here the graph in minus pi to 0. Yeah, in minus pi to 0. In this interval, if you draw the sec in like sec x graph, it will be looking like this, and like this only. Your graph is looking like this. So if you draw any axis, like any line parallel to x-axis, it will cut only at single point to the graph in this interval. Only like this graph, and this graph is this. Okay, so that is why it is 1 1 and on 2 in this interval, and your minus pi by 2 point is excluded in this interval. Why? Because at that point your graph is not defined yet. Minus pi by 2, you can see that there is a break. The graph is asymptotic here also, and here also. It is approaching to infinite or minus infinite at both sides. So like LHL and RHL are not defined yet. So graph is not defined yet. So that is why we have excluded the point minus pi by 2 to here. And that is why it is called the principal branch of cosec, like sec inverse x. Principal branch of sec inverse x. Okay. So other branches are also there, like 0 to pi, minus pi by 2, but we will concentrate only on 0 to pi minus pi by 2 is called the principal. Okay. So this is this one interval is, I would told you that this is one interval, but we will take the principal branch as only 0 to pi minus pi by 2. So this interval is yours. I apologize for that, and apologize for that. That this is for your like triple branch value branch 0 to pi, okay, minus pi by 2. In this interval also this graph is 1 1 and on 2, and that is why we will cover this point only. Okay, so this is your principal branch of sec inverse x. So sec inverse has the domain like r minus 1 to 1, that is similar to what, cosec inverse x, and its range will be 0 to pi, that is where it is principal branch value of this, minus pi by 2. Minus pi by 2 is why? Because at minus pi by 2 is there because at pi by 2 the graph is approaching to infinite, or you can say that it is not defined at that point. Minus infinite plus infinite it is approaching, and these are not defined at that point. LHL and RHL are not defined. The graph of the function y as sec x and y sec inverse x are given in the, so sec x and sec inverse x graph are given here. It is drawn by taking the mirror image about y equal to x axis. Okay, you should like know how to draw these graphs. Okay, you can take the mirror image or reflection of that graph about y equal to x, and correspondingly you can draw the graph. Okay, so let's move to the next page and see what is the next topic. Okay, so finally we should discuss the tan inverse and cot inverse graph. So tan inverse is also very important for you, and we will see that how the graph is like drawn and what is the domain and range of tan inverse also. Okay, so let's start the tan inverse function. We know that the domain of the tan function is the set of x, that is x belonging to capital R, and x is not equal to 2n plus 1 pi by 2, because at b point the function will be not defined and n belongs to z. This I already told you in the like starting of this chapter, that tan x is not defined at 2n plus 1 pi by 2. Okay, it means that tan x function is not defined for odd multiples of pi by 2, that I already told you. If you restrict the domain of tangent function to minus pi by 2 to pi by 2, then it becomes 1 1 and onto with its range as a real number. Okay, so that we will see that how it will become 1 1 and onto here. See here the graph of tan. Okay, if I can recall you that this is the graph of tan, and if I just take a domain here from minus pi by 2 to pi, so minus pi by 2 to pi by 2, but not the like your closed interval, because at minus pi by 2 and pi by 2 point the graph is not defined. So if I take the if I include both the points, then it will be not defined in this interval. So the domain should be open interval minus pi by 2 to pi by 2. So this should be the principal branch, not domain, but this should be the principal branch where tan function should be like taken, and so that we can define its like inverse at this, like in this interval, that you can see that tan is only your 1 1 function. Okay, you draw any line, it will cover cut only at single point, and it is also covering all the points in the real number line. You can see that it is covering all the real number points. So it is 1 1 also and on 2 also in this interval. So yeah, and if you like want to draw the graph of tan inverse x, so it is like this is your pi by 2, this is your minus pi by 2, this point is minus pi by 2, this is pi by 2, and this is your like tan x graph. Okay, this is your tan x graph, and how will be your like y is equal to x graph? Yeah, y equal to x graph will be like this. It will be upper side in this interval, but it will go like this below this, and from here also it will be like like below this, then it will cover like this. Okay, so if you take the reflection about this axis, y is equal to x axis, so how the graph will come like that? So just to make sure that you uh, if you take reflection of this, then it will like look like this only. Okay. And if you take the reflection of this part, if you take the reflection, it will be looking like this. So your graph of tan will be like, if you take here for interval minus pi by 2 to minus pi by 2 to pi by 2. Okay, this is the range of this function. So in this interval, the graph will look like this, and this, which I have drawn in just this one. So it will look like this. Okay, and this point is what? This is your 0 point origin, and this will be minus pi by 2 to pi by 2, and the graph will go on like this only. Okay, so that is how the tan inverse graph is drawn, and it has the like domain will be equal to what? Domain is your you can clearly see that domain is here like a real number, because it is covering all the points from like minus infinite to plus infinite. You can see here that this graph is going like this, and this it's covering all the points from here to here, but its range is minus pi by 2 to pi by 2 in open interval. Okay, not closed interval but open interval. So I hope that you got the point that how the tan inverse x graph has come, and what is the range and domain of this function. So yeah, let's move further and discuss the last function, that is cotangent function or cot function. So I will clear this drawing. Okay. So yes, we know that the domain of cot function, yeah, means a cotangent function is a set of all x, that is x belonging to capital R and x is not equal to n pi, where n belongs to your z, that is integer, and range is capital R. It means that cotangent function is not defined for integral multiples of pi. So this I already mentioned in the last starting of chapter, that it is not defined for integral multiples of pi. If we restrict the domain of cotangent function to 0 to pi, so that is similar to what? That is similar to your cos, but here the interval is open, 0 to pi open interval. Okay, then it is a bijective with and its range is R. Okay, so in this interval it will become bijective and its range is also R. In fact, cotangent function is restricted to any of the intervals minus pi to 0, 0 to pi, pi to 2 pi. That is already I have told you that we can take any interval, but the principal interval is what, where the origin is also coming like that. So that is your principal interval. And so it is bijective and its range is capital R in these all intervals. The coordinates can be defined as a function whose domain is capital R and range as any of the function. So you can analogically say like tan function as a domain capital R. So cot has also cot inverse, like tan inverse has domain that is capital R. So cot inverse has also a domain which is equal to capital R. Okay. So we will see that how that cot function has cot inverse has come. Okay. So look here. If you see that cot function is like going like this only, that it is just opposite of tan, it will go like this. Okay. So we will restrict the interval from minus pi by 2 to pi by 2 only. Okay. Minus pi by 2, sorry, 0 to pi only. 0 to pi. So 0 to pi, you take this interval. In this interval, if you see that the graph is approaching uh, to plus infinite also, and it is going towards minus infinite also. So at 0 and pi, 0 comma pi, the graph is not defined. Okay, that is why we have taken it in open interval. Okay. So now we will take its reflection, and if we take the reflection about y equal to x, we will get the graph like this only. Okay, you can draw it by yourself. That how I drawn the graph of tan inverse x, you can draw similarly for cot inverse x only. Okay, so what is the domain of this cot inverse? That is like real number or real number, because it is covering all the real numbers on the number line. And similarly, what is the range of this function? So 0 to pi is the range. Here 0 to pi in the open interval, because these points are not included in the range. These are like not defined points in the range of this function. Okay. So I hope that you all have enjoyed today's session and also got to know some points like what is your inverse function and how it, like trigonometric inverse function are defined. What are the trigonometric functions actually, and how the like sine inverse, cos inverse, and cosec inverse, tan inverse, sec inverse, and like cot inverse, how they are defined. So what are the principal value branches of that? What are the domains and ranges of that? So I hope that you got all the points today. And this is like basic of this chapter, starting of this chapter. We will see other things also in the next lecture, like some questions of this topic, like inverse trigonometric inverse functions and some properties also. And today, this is like enough for today. And if you have any kind of doubt or any type of query, you can comment in the chat box or you can ask from us. And if you want any private session also or one-to-one session from GoAsk Technology, you can get comment also, and you can ask also from us. We will arrange for you. So till now, I hope that you got all the things, and I will close this lecture now, and thank you and good day.